Hello everyone and welcome. Today we have new LeetCode problem 2874, maximum value of an order triplets 2. It's kind of the same problem that was yesterday, but we have different constraints. So the most simple brute force approach with time and space complexity of n square wouldn't work in our case. So let's dive in description. We are given a zero index integer array nums, and we should return the maximum value over all triplets of indexes I, j, k. As in previous description was mentioned, we shouldn't look for I less than j and j less than k. From the value triplet indices, it should be equal to difference between nums I and minus num j multiplied by k. So here is the example. As you see, starting, we selected in output 0, 2, and 4, which mean 12, 1, and 7, and return 77, because it is the maximum value of our triplet indexes. So the idea that we want the maximum value for nums I, the smallest value for j, and then the biggest possible for nums k. So also we can pay attention to that it's not necessary to be the nums biggest and the nums I, the biggest, num j, the smallest. Our goal is to get the biggest difference between them, and then the biggest num k, which we can multiply this difference. We are given a few hints, like check it out. We recommend to use prefix max. That's a good point. We can use nums maximal prefix. Pretty good indexes, yes. It's a good understanding. For this problem, we will use a greedy approach. The main thing that we should pre-calculate values. So we will use only one loop to pass it, and we will have all of three variables. So let's write. Algorithm will be greedy. Then we will start with variables. We will need result, which we need to return something. The maximum value of all triplets. We will then use different, so the difference between nums I and nums j. And lastly, we need left. Left represent the left side, so nums I. For example, the first variable. And all of them will be equal to 0 for now, as we will update them in the loop. Then we will start for loop. This will be advanced for loop. We'll use for k in nums. K will be representing of all elements, so we will use it to check all possible variables, integers that we can use. Now it's necessary to pay attention to greedy approach. Why it works perfectly here? Because we can use built-in function with max. So we start with rest equal max rest, and then we just copy this formula. We use difference and multiply it by k. So the same as here, just we pre-calculate the nums I minus nums j in the next line. So we'll use different will be also equal to max different. Here we will use left, so our first pointer, first side, and we will minus is from k, from another element. So their difference will be the maximum difference that we can find. So the biggest value that we can make by subtracting nums I from nums j. And lastly, we need to update the left itself. It's easily, we just used left, and our pointer that we move. Okay. After that, we will return res. So let's take this and it's passed. And let's submit. And it's pretty good runtime. One last thing I would like to take your attention to. The greedy approach doesn't work perfectly in all cases. So for example, here it works perfectly with time complexity of on, as we only pass single time loop, and space complexity of big O 1, because we have only this variable, so we may put like that. Space complexity here, and time complexity will be related to for loop, because we only check with single pass. Then greedy works perfectly because of the built-in method max. What do we mean by this? Our requirements is to return the maximum value of over triplet indexes, which means we should calculate the maximum value in each step. And for example, there's an issue with greedy, like if we need to return value 6, and we can make this value from an array. For example, we will have like 1, 3, and 4. The greedy approach will be to choose the biggest value, then to choose the next biggest if possible. So we will choose 4, then we choose 1 because we cannot choose 3, and we choose 1 and again, then equals 6. Well, the most efficient way here will be to choose 3 2 times. That's why max help us here, because even if, for example, we move our left pointer to another value here and it will calculate less that was done previously, our rest already updated with the max value. So even if in the future we will return less value than, for example, this case, less than 77, it wouldn't be updated. This is the beauty exactly of using max formula. So let me know your thoughts or questions in the comments below, and thank you for watching.